Good morning, students. In this video, we are going to see the extraction metallurgy of aluminium or extractive metallurgic process of aluminium. Okay, our title is Unit number 8, the periodic classification of elements, and the subtitle is Extractive Metallurgy of Aluminium. Then, first we're going to give the introduction about the metallurgy. I already said metallurgy is one of the department to extracting the metal from the ore after a mining process or evacuating a process. But after we are getting a ore is nothing but a complex of minerals. We are getting a complex of minerals at a certain process. We are distributed or separated from a two minerals from the ore. Finally, we are getting a pure form of metal. So we get a pure form of metal means we have a n number of process to get a ore to pure metal. Now in this video we are going to see the extractive metallurgy of aluminium. Nothing but we are going to see the what are the methods is involved. We are getting a ore to pure aluminium metal. Then aluminium is the metal found most abundantly in the earth crust. Okay, this is one of the metal is majorly available in our earth place. Then ores of aluminium and formulas: bauxite Al2O3.2H2O, then cryolite Na3Alf6, then corundum Al2O3. Here the bauxite is one of the chief ore. So chief ore is nothing but this ore is very useful to getting a high yield. Okay, comparatively cryolite and then corundum is also having the aluminium, but in bauxite is having a majority of aluminium as well as the ore to pure form of aluminium metal is getting a very easily. Okay, then what are the methods or involving in uh, process of ore to aluminium? First one is conversion of bauxite into alumina. Conversion of bauxite into alumina. It's a Bayer process. Bayer is one of the scientists. He is a found that process. So only we are giving a Bayer process. Then electrolytic reduction of alumina in Hall-Heldrod process or Hall's process. Okay. Then this conversion of bauxite into alumina Bayer process is nothing but a simple process. This conversion of bauxite into alumina involving the following steps. Okay, it's nothing but then conversion of bauxite into alumina Bayer process. What are the processes involving? We are getting a alumina bauxite to pure form of aluminium metal. First, a bauxite is a ore finally grounded and heated under pressure with a solution and concentrated with a caustic soda solution at 150 degrees centigrade to obtain a sodium meta-aluminate. Nothing but we are having a ore. Ore is nothing but a complex of mineral. Then we are adding a caustic soda is nothing but our washing boards is containing a caustic soda. So you assume you can the concentrated means the ions will be very tight, very close to each other. Solution is called concentrated. I explaining whether I am taking the solution lesson, the concentration solution and the dilute solution. What is the difference between concentration and dilution means you can assume. Here we can using a concentrated caustic soda. Caustic soda is nothing but our soap solution. At 150 degrees centigrade, we are getting a sodium meta-aluminate. The precipitate is filtered, washed, dried, and ignited. Ignited is nothing but pressure. We are placing that sodium meta-aluminate in one chamber, nothing but a microwave oven. We supplying a heat. We get a alumina. How the chemical reaction is happening? This is our sodium meta-aluminate. Then under a 1000 degrees centigrade. Okay, once we are having a bauxite, we are converted into Al2OH3. Then under high pressure and at 1000 degrees centigrade, we get a alumina plus water. The water get evaporated at this temperature. We get a pure form of Al2O3. Okay, this process was Bayer's process. This is a simple process but cost effectively very high product, because the furnace and then precipitate wash, that are the things is little bit expensive. So only nowadays we are moving to very cheap method, the electrolytic reduction of alumina Hall's process. Electrolytic reduction of alumina is Hall's process. Hall's process is nothing but one chamfer is there. One chamfer is there. A chamfer in between, we are placing a cryolite. Cryolite is a one of the ore of alumina. Okay, cryolite. Then we are inserting a three electrodes. We are inserting a three electrode. That electrode is nothing but bunch of graphite electrode. This is a graphite electrode. Then we are connected with a one wire. We are connected with a one wire is nothing but a bus bar. Then we are getting a molten alumina. We are getting a molten alumina at a bottom. We are getting a molten alumina at bottom. Then see this is a carbon. Graphite is a one type of carbon. This is act as a anode. This is act as a anode. Then the inner carbon material. The inner carbon material is nothing but the coated material. Then the carbon cathode lining. The carbon cathode lining is nothing but this is a cryolite chamfer. This chamfer for the yellow color is fully carbon cathode lining, because we are having an anode but we don't have the cathode. So the cathode, the carbon lining is act as a cathode. See, assume this graphite also a one type of carbon. This cathode also a one type of carbon. Okay. The electrolytic process is why chief means the anode and cathode was carbon. Anode and cathode was carbons. Okay. Just see, this wire is connected with the base bar. This is nothing but a plus. This is a plus and minus. We are supplying a current means the whole cryolite will be melted and settled down the bottom. The settled down the bottom. This bottom is called as a molten alumina. This bottom is called as a molten alumina. The unwanted materials are going to out. Then we can decant this side. We can get a pure aluminium metal. Very cheap metal and cost effective method. So only we are using this method as preparing a ore to metal is nothing but especially in bauxite ore to alumina. Then the steel cell is protecting layer of chamfer, protecting layer of chamfer. So okay, now we are going to see the alumina is produced by the electrolytic reduction. Now I explaining the diagram, schematic diagram, but I given the clear statement about the schematic diagram. Alumina is produced by the electrolytic reduction of fused alumina Al2O3 in electrolytic cell. So Al2O3 is nothing but cryolite, one type of ore. We are placing it in the cryolite and the mold chamfer. Then we are inserting a cathode. Cathode is nothing but a iron tank, copper tank, sorry, carbon material with graphite. The anode, a bunch of graphite. In top, we are seeing the bunch of the graphite is suspended the molten electrolyte. What are the electrolytic solution? Pure alumina plus molten cryolite and philosopher. Philosopher lower the fusion temperature of electrolyte. Philosopher is a one of the combination ore of alumina. So pure alumina settled down and molten cryolite and coming on top. We are getting a pure alumina on bottom. Then we can suspended from the opener is there. Then open we can get a pure form of alumina. The exact temperature should maintain the system, the 900 to 950 degrees centigrade. What are the voltage we are using? 5 to 6 volt. So cost is very less. The overall reaction involving the process, this is we are taking, this is we are getting. Okay, then this is evaporated. Oxygen get evaporated. Very simple method for preparation of aluminum to bauxite to alumina, pure form of alumina. Okay. Then we are find out the metal. We can find out the ore. Then we are find out the process. What are the processes cheap? Then we are getting a metal. So we are getting a metal means we should have some useful. So the metal should having some physical and chemical strength. So now we are going to see the physical properties of alumina. First I said physical color. You should identify the color. So the color of the alumina is silvery white metal. You know we are using as a aluminum vessels, utensils, our home and kitchens. Then It is low density 2.7 and it is a light. So only aluminium vessels are very somewhat weight, okay, not much weight comparatively the copper and bronze vessel. The aluminium vessel is very less weight and then easily handleable. The malleable and ductile means the metal is having a property to making a one shape to another shape, and ductile means it's making a wire form also. It's a good conductor of heat and electricity. In our big electric towers is having a aluminium wire only, because is having a corrosion is very less and having a good conductor of heat and electricity. The melting point also very much little bit high, okay. It can be polished by producing a shiny attractive appearance. So only a new aluminum vessels are very attractive. Then the chemical properties of aluminium, that should having some of the chemical properties. So we having a four type of alumina. We are paused with three. We can get a aluminium oxide. That is nothing but a cryolite. This is this is one type of poisonous material. Poisonous material, aluminium nitrate. We are frequently using the aluminium vessel and washing with the some of the nitrile and nitrile washing powders, we can getting a aluminium nitrate. So this aluminium nitrate is losing the aluminium property, so only it's become brittle, okay. The brittle means easily break. Reaction with air. So aluminium easily reaction with the hot air only. Hot air is nothing but steam. Okay, we are passing a aluminium. The aluminium gets softer and then little bit of hydrogen gas is evolved. Then reaction with alkali. Alkali means the soap solution. So only we are frequently using some of the soaps for aluminium compound. The aluminium compound is corroded like the flaky substance will be coming out. Then finally that will spoil the nature. That is explaining here. The caustic alkali forming a aluminates. See, sodium aluminate. The sodium aluminate is not stable compound. So aluminum used as a reducing agent. Aluminum is a powerful reducing agent when the mixture of aluminium iron mixture of aluminium powder and iron oxide is ignited and later it reduces the metal. This is known as aluminothermic process. This is an important question. Aluminothermic process is nothing but, first you can understand aluminum is a powerful reducing agent when the mixture of aluminium powder and iron oxide, aluminium powder and iron oxide making a powder, ignited means we are supplying a heat and melted and the later on reduced to a metal. Okay, aluminium powder and metal powder. We combined making a powder forming and combined and both are melted at the same temperature and giving a same metal. That is called aluminothermic process. Uses of aluminium. Aluminium used as a household utensils, then electrical cable as industry, making aeroplanes and other industrial machine parts. Why especially making aeroplanes means this is a weightless compound, easily flammable in a air. So industrial machine parts means instead of using a stainless steel, we are using a aluminum for a this one. Thank you.